A single tactile push button that turns a circuit on and keeps it on, then switches it off again with just another tap. That's exactly what this push-button soft latch switch does, using nothing but 4 transistors, a handful of resistors, and one small capacitor. Here's the schematic, and here's the same circuit built out on a PCB. Now let's wire it up and go through exactly how it works, one connection at a time. In standby, current trickles down through 2 470 kiloohm resistors, slowly charging a 1 microfarad capacitor up to around half the supply voltage, close to 6 volts. At this stage, every transistor in the circuit is fully off. The lamp is dark, and the circuit is drawing practically zero idle current. Now tap the button. The voltage stored on that capacitor fires straight into the base of the first 2N3904 NPN transistor, switching it on. As it turns on, it pulls the base of the 2N3906 PNP transistor low, switching that on too. The PNP transistor now feeds voltage back to the first NPN transistor, keeping it turned on continuously, even after the button is released. That feedback path is the latch, and once it closes, the circuit holds itself in the on state on its own. With both transistors conducting, the TIP42 power transistor switches on, and the 12-volt lamp lights up bright. While the circuit sits in this on state, the second 2N3904 NPN transistor fires up as well. It grounds out the resistor divider network, and that steadily drains the 1 microfarad capacitor all the way down to 0 volts. This is the circuit quietly resetting itself, getting the capacitor ready for the next press. Tap the button a second time, and everything reverses. Because the capacitor is now sitting at 0 volts, it pulls the first NPN transistor's base straight down to ground instead of firing it on. That breaks the feedback loop instantly. Both 2N3904 transistors fall out of conduction, the 2N3906 PNP transistor switches off, and with its base drive gone, the TIP42 power transistor shuts off too. The 12-volt lamp goes dark, and the whole circuit drops back to its original standby condition, with the capacitor beginning to recharge for the next cycle. That's the complete working of this soft latch. One tap builds a self-holding feedback loop and switches a power transistor on. A second tap lets a fully drained capacitor break that same loop and switch everything back off. No flip-flop, no timer chip, no mechanical latch to wear out. Just a capacitor and 4 transistors doing all the decision-making. Because the standby current is so low and there's no mechanical contact involved, this soft latch design shows up everywhere in battery-powered electronics, from single-button power switches to auto power-off stages built around microcontrollers. Change the TIP42 and its resistor values to suit a bigger load, and this exact same push-to-latch, push-to-release logic scales up to switch almost anything. If this breakdown made the push-button soft latch switch click for you, give this video a like and subscribe for more circuit explanations like this one. See you in the next video.